Hey guys, it's Mr. Mock. I promised you a movie going over some of these problems, and so here it is. Wanted to start with number one because a good handful of you are getting this one wrong by calling it can't be determined. Couldn't think of that phrase. Anyway, so let's talk about what we've got working here. What we see is we've got angle A is congruent to angle R. The two sides here are congruent. So we need to either find another angle that's congruent, or, well actually that's really about it, or this side. If we could find that these sides are congruent to each other, then we can say that we've got side, angle, side. Or we would need angle, side, angle. So can we prove that these two angles are congruent? And the truth is we can. These are vertical angles. If you remember back to earlier in the year, vertical angles are congruent. So whenever you have two lines that are crossing, you create opposite angles or vertical angles congruent to each other. So this is actually, so triangle AMD is congruent to RMC because of angle, side, angle. Alright, so that's that one. We'll move on to the next number I wanted to do, which was number, why not? Let's just do number 7 here. Number 7, it's asking, is FAD, or what is FAD congruent to? Is it congruent to something? So what do we find here? We've got FA is congruent to FE, and ED is congruent to AD, but that's only two sides. So we would need to know these angles, so maybe we could do side, angle, side, but those angles aren't congruent. Another one we could look at would be side, side, side. So do we know, is FD congruent to FD? Oh yeah, it is, because it's the same line. So what we have here is that FAD is congruent to FED because of side, side, side. All right. Here's that one. Let's see. Another one would be, oh yeah, I want to do number 13. This one here. So we're given that BL is parallel to CK. Good information. It doesn't say, though, that those two sides are congruent. In fact, it doesn't give us any information on any congruent sides. All we know with this particular example is we have alternate interior angles K and B would be equal, L and C would be equal, and then this here, these would be equal because of vertical angles are congruent, but that's just AAA, and that's actually not a conjecture that works for us. We can't determine congruent triangles based on just their angles being congruent. So this one's actually, it does not, it cannot be determined, and that would be why, for when you explain why. Last one, number 15. 15 proved to be tricky for a lot of you. This one you can do. SLN is equilateral. That means all the sides are equal. All the angles are equal then as well. Is TIE also equilateral? And here's how we can go ahead and think about this one. Since we have an equilateral triangle, we know that this angle here, N, is congruent to S, is congruent to L. We also know that this side here is congruent to this side here, congruent to this side here. So we have these three littler triangles here, right? We already have one side is congruent and an angle is congruent. So what we would need to know is another angle or another side. Can we prove that this side here is congruent to that side here, congruent to that side there? Sure, because we know that this is an equilateral. That means all these are equal. So if each of these parts are equal, then TS is going to have to be equal to IL is going to have to be equal to EN. Therefore, we can say because these are all equilateral, or because these three triangles are equal, because of SAS, side, angle, side, we can now say that this corresponding part of each of those triangles is congruent. So this would be an isosceles, or I'm sorry, an equilateral triangle. Alright guys, it's about 5 minutes of information. I did a couple problems. Hopefully that helps you prepare for tomorrow's quiz. Have a good weekend guys. Bye.